Okay, so hopefully you finished your calculations and everything worked out all right. If you have any confusion, I'm going to go through all the different problems right now. This is so cool because we're actually calculating the energy values of the different energy levels in the hydrogen atom. These are real numbers. This is not made up. This is real stuff. So let's go ahead and look at it. So we're going to start with the first one. Super easy. The first one, no real calculation is needed for it, right? So the first one is going to be simply negative 2.178 times 10 to the minus 18 joules. And why is that? Because it's just this value divided by 1. And when it's divided by 1, that's it, right? So that's the value for the energy level 1. Now we're going to need to do some calculations for energy level 3. Negative 2.178 times 10 to the negative 18. And for the third energy level, we're going to divide by 3 squared. So we're going to divide by 9. Divide by 9, and that's going to get us negative 2.42 times 10 to the minus 19 joules. And then when we want to do energy level 4, what we're going to do is we're going to take that same thing. So all I do for my calculator, you guys should learn some neat ways to use your calculator, okay? So the easiest way to do for the next one is simply hit the second button. So you hit second and then the enter, and that's going to bring up your previous line that you just typed in. And everything's the same except the denominator. So all we need to do is change that 9 to a 16, right? Because 4 squared is 16. And there we go. That's our answer. So that's going to be negative 1.361 times 10 to the minus 19 joules. So there we have the energy level values for the first 5 energy levels of hydrogen. And next, we're going to use these and see, well, what does that mean when the electron goes up or down? So number 2, we're going to do some energy level differences. So this is E1 minus E2. What does that mean? That means the electron's going from energy level 2 down to energy level 1. Remember, it's final minus initial, so it's when it goes from energy level 2 down to energy level 1. Let's go ahead and do that calculation. So if you look back at the previous page, we're doing energy level 1 is negative 2.178 times 10 to the negative 18th. And then we're going to subtract energy level 2, which is, well, if you're subtracting a negative number, we can just turn that into a positive. So you can do it if you want. You do subtract a negative, but the same thing, we're just adding to that. So that's going to be adding 5.445 to the negative 19th. And let's see what that is. Right, that gives us a negative number. It's negative 1.634 times 10 to the minus 18th joules. All these have the units of joules. Energy is measured in joules here. And that is going to be the energy that is lost when the electron drops from energy level 2 back down to energy level 1. Okay? And so we can continue to do this for the next one. Once again, we can use the second entry to come up with this whole thing again. We don't need to change the energy level 1 because that's the same in this case. All we need to do is to change the second one. So that's going from energy level 3. Energy level 3 is negative 2.42. 2.42 to the negative 19th. So I'm just going to make that 2.420, or you could delete that number. That's fine. Times 10 to the negative 19th. And that gets us negative 1.936 times 10 to the negative 18 joules. Notice that this number has an absolute value greater than that, which makes sense because the electron is going down more when it goes from energy level 3 down to energy level 1 than when it goes from 2 to 1. Okay, so we'd expect a larger difference in energy, which is what we have. All right, one more here, going from energy level 4 down to energy level 1. So I'm going to once again bring up my previous entry and just modify this number here. So we have Once again, negative 2.178 times 10 to the minus 18 minus a negative number. So we're just adding to that. And the energy value of energy level 4 is negative 1.361 times 10 to the minus 19. I hit enter, and here we go. I have negative 2.042, rounding up there, times 10 to the minus 18 joules. So these are all the differences in energy when an electron drops down from energy level 4 to 1, 3 to 1, or 2 to 1. This, as expected, is the largest absolute value, and this would be the smallest. So all of these are negative because the electron is losing energy, and that energy is being converted into a photon. So the energy is not being lost and going to nowhere, but is turning into a photon. Now, number 3, calculate the energy difference when an electron goes from n equals 2 to n equals 3. So in this case, that's going to be E3 minus E2. In this case, the electron is going up in energy level. So it's going to absorb a photon in order to go from n equals 2 to n equals 3. So let's go ahead and do that calculation. So that's going to be the energy for n equals 3, which we calculated to be before. And I'm just going to type this in my calculator. That was negative 2.42. Second comma gives us that E. So that's to the negative 19th power. And now we're going to subtract a negative value. So I'm just going to add the energy level 2 value, which we previously calculated to be negative 5.445 times 10 to the negative 19th. All right. When we combine those together, we notice that now we have a positive value. So this is going to be 3.025 times 10 to the minus 19 joules. The positive value here simply tells you that electron is going up in energy level, is gaining energy, and so therefore a photon must be absorbed and not given off. And so in the previous problem, is light given off or absorbed? It is absorbed because that's a positive number. Calculate the wavelength of light in nanometers given off or absorbed. And so in order to do that, we simply say, okay, we know the energy of the photon. In order to cause the electron to go up in energy level, the energy of the photon must be the same value. It must be 3.025 times 10 to the negative 19 joules. And then from there, we're going to calculate the frequency and wavelength of that photon. So once I have this energy of the photon, then I can use these other equations that I have over here to calculate the frequency and then the wavelength. All right. You could actually combine these equations to do this in one step, but I'm just going to do it in 2 steps for you guys. So we have E equals H nu. So we want to calculate the frequency, which means the frequency is going to be E divided by H. And I already have H stored in my calculator, which I recommend you doing. It's going to save you some time. So I have this number. This is the energy. And then I simply take that and I divide by H, which gets me 4.565 times 10 to the 14th. What are my units? For frequency, my units are going to be hertz. And that makes sense because your value for energy is in joules and H is in joules seconds. So joules over joules cancel and you have per second, which is hertz. Next, we're going to calculate the wavelength. And we already know that the wavelength is going to be C divided by the frequency. Okay, and you can get that from this equation right here. C is wavelength times the frequency, and so wavelength is C divided by frequency, or you can also calculate your frequency is C divided by wavelength. They're both, whether it's frequency or wavelength you're calculating, is simply the speed of light divided by the other number. All right, so that's going to get us, and once again, I have C stored in my calculator, which you should too, to save you some time. So that's going to be C divided by my previous number. And that gets me this 6.567 times 10 to the minus 7 watt. My units must be watts. If C is in meters per second and nu is in hertz, that per second cancels out and we're left with simply meters as my units. And that makes sense because it's wavelength and length is measured in meters. So it tells us one last thing. It wants the wavelength in nanometers. And so to convert this into nanometers, we want something times 10 to the minus 9 meters. And if this exponent is getting smaller, this number here must be getting bigger. So we're going to take this decimal point and move it 2 spots to the right. So that's 656.7 times 10 to the minus 9 meters, which is 656.7 nanometers. There we go. We're all done, which concludes this lesson and concludes this unit. So hopefully you guys had a good time learning about the atom. Stay curious. Chemistry is fun.